All right, moving on to section 2. We are still talking about matter, but this section is going to focus on how we measure that. Again, scientists like to measure things. That's how we tell things. You just did your whole ESP experiment. You had to measure your data somehow. So these are different ways that chemists are going to use to measure matter. Most of this should be a review from last year. So this section is not too demanding, hopefully, for you guys. But again, a lot of terminology is going to happen, so you got to know those key terms. First thing we're going to talk about is weight. Weight is a measure of a force of gravity. That is extremely important. Weight is a force of gravity. It is measured based on gravity. If you have no gravity here, you have no weight. If you are falling from the sky, the only force acting on you is gravity, and therefore you don't have a weight. It's gravity pushing on you and you pushing on something else. So think about it with a scale. You stand on a scale, gravity pushes down on you, you push down on scale, scale reads your weight. That is weight. Do not confuse weights with mass. Mass has absolutely nothing to do with gravity. Gravity could be any amount you want. Mass is not going to change. So with that idea, scientists tend to go with mass more often. It is just very nice that our weight and mass on Earth are equal. They are not equal everywhere else, though. But for most of our parts and for most of what you're going to be doing, especially this year, mass and weight are pretty much going to be the same measurement. They're going to give you the same value. However, they do have some distinct differences. Mass is going to be the amount of matter inside the object. That's how much stuff is in there. You can think of it that way. Mass is stuff. I know it's kind of a word people frown upon using, but mass is, for lack of a better word, the stuff that makes it up. Mass is not going to change based on your location. So looking at a little graphic, mass stays the same no matter where you're at. Mass is always the same. Mass is also going to be a physical property, so it is going to be something that is measured, like temperature we discussed in the last video. That is a physical property. Mass does not change where you are, weight does. You'll also take note that weight here is measured in units called newtons because newtons measures a force. We'll talk about that in the second half of the year when we get into physics, but note that weight is measured here in newtons because it's referring to a force. However, mass is measured in kilograms because that's what we measure mass in. So we do use our SI system, which is our System International. It is a French system of measurement, probably more known to you as the metric system. It is the same thing. Your base unit for mass is a kilogram. That is a little strange compared to other base units because here a kilogram has a prefix of kilo to it. The other ones, like the base unit for length, would be meter. It's not kilometer, it's just meter. Here, the base unit is not gram, it is kilogram, which means all of your mass is based off of the weight, sorry, not the weight, the mass of a kilogram. Of course, mass and weight are the same on Earth because the gravity is what we base everything off of, is Earth's gravity. But it is a measure of how much stuff is inside. Just quick conversions, it takes 1,000 grams to make 1 kilogram. The metric system is pretty easy on the math, so we're not going to get too far into that. Our next quality of matter that we like to measure is volume. Volume refers to the amount of space that an object takes up or it occupies. You can think of a lot of volume as in different states of matter. Again, if you review the last videos on physical changes, a change in state or a change from a liquid to a solid to a gas is just a change in matter. It is a physical change. You're not creating a new substance, but you are changing its state. And in different states, you're going to have different properties for volume. You can take a good look at a balloon, for example. This is one example of mass staying constant. I am not adding more balloon to it when you blow it up, but when I fill it with air, the balloon stretches out and takes up more space, so it does increase its volume. Units for volume, your base unit is going to be your liter. You're also going to get milliliters. Pay extra close attention to abbreviations. Liter is a capital W. or capital L, sorry. Milliliters is lowercase m, capital W. It is very important to get units right. I will be marking units wrong. So if you decide to put this as a capital M and a capital L, it's wrong. Sorry, that is not a milliliter. That's not anything. It means nothing to me. So make sure you're getting the right units down. Another way to measure units is cubic centimeters. We use this measurement mostly for solid objects in the solid state. You can abbreviate that as cm with the cubed, or the 3 as an exponent. Keep in mind that 1 cubic centimeter is the same thing as 1 milliliter. Again, we like to use the cubic centimeters here for solid objects, and for liquids and gases we tend to use the milliliters. And we measure them using a graduated cylinder. Again, last year you had plenty of practice with these, so I'm hoping this is a review, but it is this instrument here, and you'll note that it has very precise graduations on. Calculating volume, if you don't have a graduated cylinder, especially for solid objects, is a bit rough because, well, you can't fill up a graduated cylinder with it. It's a solid. It doesn't take up all the space that you let it take up. It takes up a certain amount of space, no matter where you put it. So we do have a mathematical formula for it. Volume is going to be length times width times height for rectangular objects. You're not going to get much into it. Right now, just using this formula, if you could figure out the volume of this, again, all you're doing is taking length times width times height, so 3 times 2 times 5. You'll get the volume of this object. Do not forget your units. Here we are measuring in centimeters. We have 1, 2, 3 centimeters cubed. Look at that. So here it is again. We have the 2 centimeters times 3 centimeters times 5 centimeters. Again, it's centimeters times centimeters times centimeters. That's where our centimeters cubed comes from. And 2 times 3 times 5 gives you 30. So our volume is 30 cubic centimeters, or centimeters cubed. Pretty easy calculation there. Volume of irregular shaped objects is a bit tough, but we do measure this through water displacement. Again, last year you had some practice on this. But here we have our graduated cylinder. I took the graduations off just to simplify everything. But it came up to here. I dropped my object in. Water was displaced by that object up to here. The difference between them is the volume of your object. So here, whatever this number is minus this number here on your graduated cylinder will give you the volume of the key. As long as that object is completely submerged, that will work. Density is our next measurement. Density is a calculation. Density is how much mass is given in a certain volume. You can think of it, I have a map on here about population density. You can think of in New York City, you have a higher population, you have more people for the amount of space that's there than you do, say, in Montana, where apparently nobody tends to go that much. So again, you can think of that as volume. I'm sorry, not volume, it's density. Density is related to mass and volume. It's how much mass is in a certain volume. So how much of that substance is contained in a given volume. Your units are going to be related to mass and volume. For example, mass is your grams, volume is your centimeters cubed. So this is grams per centimeters cubed. It is a combined unit. Going more into density, density determines whether you sink or float. It is not based on mass alone. It is not based on volume alone. It is not based on how heavy you are. That would be weight. That's something we don't even measure anymore because we're looking at mass. But if you think about it, huge freight ships weigh a whole bunch, but they don't sink. They still float because they have a low density. Density determines it. The density of water is something you should know. Water is 1 gram per cubic centimeter. So this is your density of water. Anything that is less than the density of water will float. Anything that is greater than will sink. So if you have a basketball, it's mostly filled with air. You have little mass over a large volume. That makes that ratio go down, and therefore you have a low density. So therefore you will float. A bowling ball, on the other hand, has a high mass and it's even in a smaller density. It's smaller than a basketball, so it's a smaller volume there. So high mass, small volume, that means large density, and therefore chances are it's greater than 1 and it will sink. Here's an example of how you calculate density. Again, it is a mathematical formula. Density is going to be mass divided by volume. Pretty simple to get, mass, volume. So here's your example. Please take a minute to read the problem and solve it. A block has a mass of 200 grams and a volume of 250 cubic centimeters. What is the density of the block, and can the block float? So again, density is mass divided by volume. So you take your mass, 200, divided by your volume, 250, and you'll get your density. Go ahead and take a minute to do that. And then tell me, is that density greater or less than 1 gram per cubic centimeter? And if it is greater, your object will sink. If it is less, your object will float. So just to check yourself, you should be getting 8/10 grams per cubic centimeter. Make sure your calculation is correct, because you will get points deducted for any of these things wrong. So make sure you get calculations correct. You're being careful with those calculations, and make sure you are providing the correct units. If you did not provide that it is grams per cubic centimeter, it is wrong. If you wrote kilograms per cubic centimeter, it's wrong. It's in grams per cubic centimeter. You are allowed to use milliliters for centimeters, but this is a solid object, so we are looking at cubic centimeters. And also, did you mention whether this object sinks or floats? Again, looking at our density, it is less than 1, so therefore our object should be floating.